Hi everyone, my name is Jordan. I'm a third year PhD student at Deakin University in Melbourne. My research primarily focuses on non-invasive brain stimulation and dystonia and how we can sort of bring these two together. So today I'm going to be talking to you about a clinical trial I'm running down in Melbourne using multi-day continuous theta burst stimulation in cervical dystonia patients. So a really quick overview of the rationale behind our study. We're looking at cervical dystonia, which is a neurological movement disorder characterised by excessive or involuntary contractions of the neck muscles. So the most common treatment for cervical dystonia is the injection of Botox into the affected neck muscles. However, this doesn't really treat the root cause of the dystonia. It's just sort of treating the symptoms of the disorder. So what we know from previous research is that idiopathic cervical dystonia is caused by abnormal activity or abnormal messaging within the brain. So another treatment we use for cervical dystonia is called deep brain stimulation, or DBS, and this works by normalising that activity within the brain, which then in turn relieves the symptoms. However, DBS is quite expensive and very invasive, so it does involve surgery and implantation of electrodes within the brain. So this means there's quite a large gap between our two most common treatments for cervical dystonia. We do need something less invasive than DBS, but also something that treats this abnormal messaging within the brain, which is something that Botox just doesn't do. So that's why we're running this clinical trial to see if non-invasive brain stimulation options, such as TMS or transcranial magnetic stimulation, might be a viable treatment for cervical dystonia patients. So what is TMS and how does it work? So TMS, or transcranial magnetic stimulation, works by placing a coil on top of the patient's head, and when a button on the coil is pressed, an electromagnetic current comes out of the center of the coil and it goes through the hair and the scalp and sort of hits that surface region of the brain, causing your neurons to fire. So TMS is safe, completely non-invasive. In fact, you're awake and talking to the technician while you're having it done. TMS is now currently approved as a Medicare treatment for depression as well, and there's quite a bit of research into using TMS as a treatment for other movement disorders, such as Parkinson's. So here on the slide, I have a picture of what the TMS machine that we're using in the trial looks like. So when we use TMS as a treatment, we use a repetitive form of TMS. So instead of having one click and a pulse is sent out, multiple pulses come out in quick succession. So the specific form that we're using is called continuous theta burst stimulation, or CTBS, and what this does is it down-regulates activity in the region of the brain that is targeted. So as I mentioned previously, research is sort of suggesting that the brain may be behaving abnormally or messaging abnormally in cervical dystonia. In fact, we believe it may be overactive in a specific region of the brain called the somatosensory cortex, which you can see on the slide here in blue. So this region of the brain is responsible for sensory processing. So we think targeting this surface area of the brain and perhaps trying to down-regulate activity here might actually help with symptoms of cervical dystonia. So now I'll just go through a few aspects of the trial in detail and how it all is sort of working. So as I mentioned before, the particular type of TMS that we will be using is called CTBS, or continuous theta burst stimulation. We're hoping to recruit 20 cervical dystonia patients who will come in for 20 sessions total of the TMS treatment, delivered over 2 blocks of 2 weeks each. So participants will receive both the real and a placebo or a sham intervention. So obviously we won't tell you, which one you're getting at any given time. So 1 block of 10 sessions will be the real intervention and 1 block of 10 sessions will be the placebo or the sham. So these blocks will be separated by a 2-week break. This is just so, we can make sure that any effects from the first block don't carry over into the second block. We'll be delivering CTBS to both sides of your head. So regardless of whether your symptoms are on the left or the right side, the intervention is actually to both sides of the head. And then at the very end, there's a 2-week follow-up at the completion of all the sessions so that we can see, if there's any effects of the intervention that sort of last beyond that treatment period. Over the course of the sessions, we will collect a number of outcome measures that assess cervical dystonia symptoms. So I'll just go through these quickly here. The main outcome that we are interested in is the TWSTRS, or the Toronto Western Spasmodic Torticollis Rating Scale. You might have heard of this before. It's a clinical rating scale that neurologists tend to use, and it helps to measure the severity of your symptoms, any pain that you might be feeling, and also the effect that the symptoms have on your everyday life. We also have a rating scale for pain specifically that we will collect every day to sort of see how the experience of pain is changing over the sessions. We are also collecting some more sort of objective measures of symptoms. So we'll be looking at the neck and head range of movement of our participants and also proprioception. So both of these will be measured using a movement sensor, which is one on the head. You can see me demonstrating it on the slide here. And we'll also be recording a video of the activities as they're being performed by the participant. So both these activities will be measured before and after each block of sessions to see if the intervention helps with the neck and head range of movement and also a participant's proprioceptive awareness. And the very last thing that we are looking at is how the brain responds functionally to the CTBs treatment. So we will be collecting MRI scans over the course of the trial, specifically functional MRI scans, which show us the activity within the brain. So because we're stimulating a specific spot in the brain, the somatosensory cortex, we're sort of hoping that over time we might see the activity in this area decrease and perhaps see other changes in how the brain is communicating as well. So I guess to sum up, to bring it all together, what we're really trying to determine here is whether TMS can be used as a viable treatment option for cervical dystonia patients with this trial. We're hoping that potentially this could fill the gap for treatment options left by Botox and DBS. I think this trial will also allow us to understand some of the mechanisms of cervical dystonia too. So it might be that the treatment helps with pain rather than the physically presenting symptoms. These are things that we'll be able to explore further with this trial. I'm also hopeful that this trial will raise awareness of cervical dystonia and dystonia more broadly. So I think many people who I've talked to have been surprised that we're looking at cervical dystonia specifically. It sort of seems to be a little bit of an overlooked disorder that even some practitioners don't know about. So I kind of hope that by talking about it and conducting this trial, we are able to raise some awareness in the general public as well. So that's it from me today. I'd like to thank Kerry and Lorraine for letting me give you a brief talk about my work and for this opportunity. It's really excellent that I'm able to get the word out here. And if you've got any questions about the trial, perhaps maybe you even want to participate, please do get in contact. My email address is on the screen there. Thanks again.